Okay, section 3.4, we're going to be solving exponential and logarithmic equations. There aren't any notes to take here. We're just going to work through several examples so I can show you some of the different types of equations that you'll run into and the steps that I would take to solve them. Okay, so on number 1, this just wants us to determine whether the value of x is a solution to the equation. So we're going to be plugging in both of these values into the equation one at a time and see if it works or not. Your work is the answer here, just showing if it works or not. So for part A, I want to plug in 5 for x. So I'm going to do 4 to the 2 times 5 minus 7 power, and I want to see, does that equal 64? So in my exponent, 2 times 5 minus 7 is going to be 3. So 4 to the third power, does that equal 64? Well, 4 to the third is 4 times 4 times 4, which does equal 64. So yes, this is a solution. Okay, so same thing for part B. I'm going to plug in 2 for x. So 4 to the 2 times 2 power minus 7, is that equal to 64? So this is going to be 2 times 2 is 4, minus 7 would be a negative 3. 4 to the negative 3, is that equal to 64? Well, when you have a negative exponent, that moves that number to the other side of the fraction and then cubes it. So this would actually be 1 over 64, which is not equal to 64. So in this situation, 5 was a solution, but 2 was not. Okay, number 2, we're going to solve for x. So I have 1/2 raised to the x power equals 32. So in some of the situations we've seen before, we would try to get both sides of the equation to have the same base, and then I could drop the bases and solve the equation that's in the exponent. Sometimes that's easy to do, sometimes it's not. Well, since we have so many other properties and rules about logarithms and exponentials that we've learned in this chapter, let's use some of those rules. When the variable is in the exponent, I have a way to bring the exponent down out of the exponent as it is. So if I take the log of both sides of this equation, then I will be able to bring the x down out front of those logs. So when I take the log of both sides, and you can do that because you're doing the same thing to both sides of the equation, log of 1/2 to the x equals log of 32. Now I can bring my x down out front. So this is going to be x times the log of 1/2 equals the log of 32. Since x and log of 1/2 are being multiplied together, I can divide by log 1/2 on both sides. So then x is just going to equal log of 32 divided by log of 1/2. Then I can type this into my calculator. Remember when you type this into your calculator that you need to close parentheses after each number before you type the next log. So when I type this in, it turns out that x is equal to negative 5. Okay, I could plug that back in, 1/2 raised to the negative 5 power, and that would equal positive 32. Okay, number 3, solve for x. Same type of thing on this problem. I have e to the x equals 2. I want to get the x out of the exponent. The last problem, we took the log of both sides. But since I have an e in this problem, instead of log, I'm going to use the natural log, which is ln. I'm going to take the ln of both sides. So this is going to be the ln of e to the x equals ln of 2. Then I can bring my exponent down out front. So x equals x times ln e equals ln 2. Now you can pretend that you need to divide by the natural log of e on both sides, or if you remember, the natural log of e is a property that it always equals 1. So x times 1 equals the natural log of 2. So then I just need to find out what the natural log of 2 is. So I type natural log of 2 in my calculator, and it is approximately 0.63 or 693. Okay, number 4, I have log base 4 of x equals 3. So when you have a logarithm equals a number, the easiest way to solve this problem is to rewrite it in exponential notation and solve it from there. So to remember to write in exponential, we use our little loop-de-loop around the equal sign. So I'm going to start with the 4. 4 raised to the third power equals x. Then I can just type that in my calculator. 4 to the third is 4 times 4 times 4, which is 64. Okay, number 5 wants us to solve the equation when f of x equals g of x. And we're given two different equations here. So I'm going to set these two equal to each other. Log base 3 of x equals 2. So this is going to be the same as the last problem. Anytime you have a log equals a number, you want to rewrite it in exponential notation. So you're going to use your loop-de-loop around, and we're going to write 3 to the second power equals x. And I know 3 to the second power is 9, so x equals 9. Okay, this one looks a little crazier. This is an exponential equation, and notice the variable is in the exponent. So what we want to do is try to get everything away from the exponent in the equation, same as we would in algebra. And then once we get to that point, what's in parentheses, then we'll see how we can solve it from there. So I'm going to start by adding 7 to both sides of the equation. So then this is going to give me 6 times 2 to the 3x minus 1 power is equal to 16. Since 6 is being multiplied times the parenthesis, I'm going to divide by 6 on both sides. So now 2 to the 3x minus 1 power is equal to 16 over 6, which reduces to 8 over 3. Now remember, I want to get the exponent out of the exponent. I want to bring it down. So in order to do that, I have to take the log or a natural log of both sides. Since there aren't any e's in this problem, I'm not going to use the natural log. I'm going to use log. So then once I take the log of both sides, I can bring 3x minus 1 down out of the exponent. So this is going to be 3x minus 1 times log 2 equals log of 8/3. Okay, so I'm going to divide by log 2 on both sides. I'm not going to type anything into the calculator yet. I'm going to wait till the very last step to do all the calculator portions. So now I've got 3x minus 1 equals log of 8/3 divided by log 2. Well, I'm still trying to get x by itself. So my next step would be to add 1 to both sides. So now 3x equals log of 8/3 over log 2 plus 1. Then I need to divide by 3 on both sides. So x is equal to log of 8/3 divided by log 2 plus 1, all divided by 3. Now I would take the steps to type this into the calculator and do it piece at a time. Log of 8/3 divided by log 2, get an answer. Add 1 to that, get an answer, and then divide by 3. So in the end, after you type this in the calculator, you should get that x is approximately 0.805. Okay, number 7. This one looks a little crazy because we've got lots of e's in the equation and several different exponents going on. So if you imagine, this is kind of like a quadratic equation in algebra. I can set up my two sets of parentheses here, and I can actually factor this out. So I want to know what two things multiply to equal e to the 2x. Well, remember, when you're multiplying two things, you add their exponents. Two variables, you add their exponents. So if I had e to the x times e to the x, that would be e to the 2x power. Now I think about my 4 on the end. 4 could be several things. It could be 2 times 2, it could be 4 times 1, but I need the combination of numbers that's going to add or subtract to equal the negative 3 in the middle. So I know that's going to be 4 and 1. And since 3 is negative in the middle, then I need my bigger number to be negative. And these are both set equal to 0. So now that I've factored, I can set both of these equations equal to 0 and solve from here. So for the equation on the left, e to the x minus 4 equals 0, I would add 4. So e to the x equals 4. And then like the problem that we did earlier, I would want to take the natural log of both sides to get the exponent down out front. So x times natural log e equals natural log 4. We know that the natural log of e is 1, so x is just equal to the natural log of 4. So I can type that in my calculator and I get that the natural log of 4 is about 1.386. Now for the other side, e to the x plus 1 equals 0. So I subtract 1 and e to the x equals negative 1. Take the natural log of both sides and bring my exponent down out front. So x times natural log of e equals the natural log of negative 1. We know that the natural log of e is just 1, so x is equal to the natural log of negative 1. Now when you type natural log of negative 1 into your calculator, you're probably going to get an error and it's going to say non-real answer. I can't take the natural log or the log of a negative number. It's not part of its domain. So this would be something that would be an imaginary number situation. So we're going to ignore that anytime that happens and you get an error when you take the log or natural log of a negative number. You're just going to ignore that answer. We're only going to use the one that worked, 1.386. Okay, number 8. I've got 7 plus 3 natural log of x equals 5. So I want to try to get the x by itself. I'm going to peel everything away from the x. So I'm going to start by subtracting 7 on both sides. So then I have 3 times the natural log of x equals negative 2. Then I'm going to divide by 3 on both sides. So the natural log of x equals negative 2/3. So anytime you have a log equals a number or a natural log equals a number, we want to rewrite it in exponential notation. Well, remember that natural log is base e. And then I'm going to use my loop-de-loop to write it in exponential. So e to the negative 2/3 power is equal to x. And then I can type this into my calculator, e to the negative 2/3, and I get that it's approximately 0.513. Okay, last one, we're going to put several things together in this one problem. We're going to use some of the properties from section 3 to kind of condense what's going on the left-hand side, and then we'll solve. So notice you have a log minus a log. Well, this is the quotient property. I can condense this on the left-hand side to be the log of one thing that's being divided. So this will be log base 4 of x over x minus 1 is equal to 1/2. Okay, now I have a log equals a number, so I can rewrite using exponential. 4 to the 1/2 power equals x over x minus 1. Well, 4 to the 1/2 power is the same as taking the square root of 4. And we know that the square root of 4 is 2. So now I just need to solve my equation. So since x is being divided by x minus 1, I need to multiply by x minus 1 on both sides. On the left, when I multiply by x minus 1, I need to distribute 2 times x and 2 times negative 1, which will give me 2x minus 2 equals the x that's left on the right-hand side. Now we want our x's on one side and numbers on the other. So if I subtract 2x, then I'm going to have negative 2 equals negative x. So that means that x has to equal positive 2.